Start us off here. So I am Monica Ciron. I am a PhD candidate at Illinois Tech, and I'm also a research fellow with the Illinois Tech Ethics Center. And the director of our center is Dr. Elizabeth Hilt, and our researcher and librarian is Kelly Loss. So thank them both for helping us with a webinar today. So I thought I'd start with giving a little bit of background on this webinar topic and why this is the topic that we're discussing. So about 4 years ago, Kelly, Elizabeth, and I all started looking at AI ethics from a variety of different fields. And it was definitely a whirlwind. So I'd like to say congratulations to anybody that has been in the AI ethics field for the past 4 years, because it's been chaotic, right? Like at the beginning, nobody knew what AI ethics was, and everyone would kind of be like, what are we talking about here? And now we've seen it really develop into a really fruitful field. So congratulations if you've made it. If you're new to the field, I think you're coming in at a really good time, because a lot of the debates and discussions that we were having 4 years ago have kind of been smoothed over, maybe not everything, but it's been really developed along the way. And then I would say that at the beginning of AI ethics, it was really more of a discipline by discipline field. And I think in the last 4 years, we've really seen AI ethics become an interdisciplinary field as kind of the primary way of approaching this topic. So, like I said, we looked at AI ethics from a variety of perspectives and fields, and we started realizing and noticing that AI can't be regulated in the same way, because AI affects every industry in a different way, and there's no like one size fits all policy or regulation that can suit this issue. So, for instance, AI does not affect law like it does journalism. AI does not affect neuroscience like it does, say, agriculture. So when it came to my own dissertation topic, I really started looking at, all right, where's my own niche in this big field that's blown up in the past 4 years? And I'm from rural Minnesota, and I currently live in rural Minnesota. And agriculture is a part of our community, our culture, our identity. And so I'd be at these big AI conferences and discussions, and we're in very metropolitan areas usually. And I'm thinking about my neighbors in Minnesota, and I'm like, does this affect them? Does this topic that we're discussing right now, how does it affect, people from my background? So that's how I started the dissertation topic of AI ethics in agriculture. So I start looking, literature review basics in the beginning. And I started finding, while there's this like huge amount of research and interest in AI ethics in general, there's really not a lot of research or scholarship on AI ethics in agriculture, especially within the Midwest. So that's how I came to my dissertation topic of AI ethics in agriculture in the Midwest. And then when Kelly and Elizabeth were, we're discussing events and webinars that we could host, we're like, all right, let's make it on this topic. And in the progress of my dissertation, I've found our two speakers today, Dr. William Aderholdt and Dr. Gabriel Thomas, who I'm really excited to hear from today, because we have academia perspective, we have industry perspective, and I think we're just really at the beginning of looking at what AI ethics in agriculture means, and I think it's a really exciting time to move forward. So I will stop talking, and I will hand it over to our first speaker, who is Dr. Gabriel Thomas, who has been a faculty member in the Department of Electrical and Computer Engineering at the University of Manitoba, Winnipeg, in Winnipeg, Canada, since 1999. And he is currently an associate professor. And his current research interests include digital image and signal processing, machine learning, non-destructive testing, and computer vision, which are all very important for our machinery and agriculture right now. So I'll hand it over to you, Dr. Thomas.
Okay, let me share the screen. It's not working. Oh, there. Okay, so let me start. Good day, everyone. So that's it. My name is Gabriel Thomas, and I'm at the University of Manitoba, so I'm not going to repeat that. So as you can imagine, I am a technical person, but that doesn't mean that I don't have a say on the ethics. And I decided for this talk, thank you very much for inviting me, is that I will give you a very personal opinion of what I think the ramifications are for applying artificial intelligence in this field in agriculture. You will notice a bias on my case, which is understandable, but it will be personal. No, I haven't done all the research that Monica is doing. So for the second part, I will give you just a brief example of something that we have done on the technical side of things together with colleagues at the University of Barcelona. So I'm going to start by mentioning that every time we think of artificial intelligence applying in industry in general, we think of automatization. No, I think that's what the general public will think of. So I was reading this source, The Guardian, a British newspaper, and very recently they were commenting on this. No, they were saying that robots are on the rise, that we already lost a lot of jobs because of the pandemic, and they were citing that report from the World Economic Forum. Then they say that by 2025, they expect that the application of this type of technology will disrupt 85 million jobs. And I think that's the concern of a lot of people. Now, here is me with my personal views. So I'm going to show you first that slide where it's an old movie, very famous movie. It's Metropolis from Fritz Lang, silent movie. I saw it when I was a kid. And of course, it's a sci-fi movie, so there will be a robot, as you can see there on the top right. But they depict a scenario where still industrial manufacturing or industrial processes were still being done by people. And as you can see there in those three frames from the picture, from the film, they don't look very happy. No? And I remember thinking when I was a kid, when I watched this movie, it wasn't released, no, as a anyway, I remember thinking, at least on my side, I believe that I wanted to do something more related to more creative job than doing something like this. And I strongly believe that when humans are involved in repetitive tasks, we are prone to fail. No, we will make mistakes, and because it seems to me that we're not very enthusiastic of doing something over and over again. And once again, this is a sci-fi, and as you can see, high tech, like a steam engine was displayed. But to me, the message here was that this is not a good scenario, no? And to me, things like automatization makes sense, no? When we have to do this repetitive task over and over again. When I was a kid, I remember working in a farm. My dad would send me to work in a farm. And I was very excited because one of the things that I did in that farm was drive tractors. No? So you're a little kid and you get to drive this big piece of machinery, you're very excited. No? And I remember the manager of the farm tell me at one point, we need to get rid of the weeds on the field. And yeah, that's a bean field. So, so he told me that, and I was looking forward to see what type of device we were going to attach to the tractor. And then he handed me one of those. And I remember I wasn't a happy camper. I remember at the end of the day, I ended up with my hands full of blisters. I could hardly grab anything. So I wasn't very happy, no. And now we have things like that. No, we have farming robots that can kill 100,000 weeds per hour. And my source for that is this homepage there. When they also mention, you know, there's also, you wouldn't like to use chemical herbicides, no? So that idea of introducing a robot like that seems like very good. Also, they mentioned that there's labor shortages in this field. They also included a piece of paper from the Seattle Times, an article, when they said that it's actually difficult to find people to work in this field. And I have a testimony on that, no, that to grab that thing and work on weeding by hand all day, that's no fun, no. To me, that doesn't mean that somebody wouldn't like it. No. Anyway, so when we involve with, now I'm going to go a little bit technical. When we are involved in applying some of these techniques into agriculture, for example, if we think of machine learning, most likely than not, we're going to have to make a series of decisions. And the first decision is what type of sensor I'm going to use to collect data that I'm going to use to make a classification, for example. No? So we start with deciding the sensors, and maybe you would like to introduce some sensors, aid hardware, like light diffusers, for example, or filters, audio filters. And the idea is to improve the quality of the inputs you're going to use. No? So you have this initial data, and then you maybe would like to even modify it a little bit more. So you introduce some software pre-processing, so like noise cancellation, or if you're working with images, you're going to enhance the contrast, etc. So once you have all this data, you have to extract features. So you will have a feature extraction step, and maybe you're extracting a lot of features. So you will have to decide from a subset of those features. So maybe you have to introduce a feature selection part where you're going to pick the best ones that will give you great classification when you introduce a classifier. Now, in what we call a supervised training mode, when you're going to train a classifier with supervision, you need the opinion of an expert. So you have an expert input that you will use together with those features that you decided were the best. Those are the inputs to the classifier, and then you're going to make a final decision at the end. No? So that's good old machine learning. In today's world, we eliminate 2 steps of this process. We don't have to deal with feature extraction and feature selection anymore. So we forget about them. In a supervised mode, we still need that expert opinion, but now we introduce, instead of using a neural network, a good old neural network, we introduce something that we call deep networks. So a convolutional neural network like the one I'm depicting there. You eliminate those 2 steps, and it seems that your life is becoming easier because now you just input those information that you collected into the CNN, and you make those same decisions, no, like steer, brake, decide that it's defective or not. So it seems that life is becoming easier, and this applies only if you have enough data. No, that's the only thing. There's nothing for free. So that number of inputs going into the CNN, you have to have a lot of them. Now, in the agriculture or farming or food industry in general, you don't have that luxury sometimes. And actually, in my experience, you don't have that luxury. So at one point, we decided, well, if we don't have enough data, where are we going to find more data? So lately, some of the newer techniques in deep networks, it's this type of generative adversarial networks. So I'm going to briefly describe what that is. And this deals with the fact that you're going to create something out of nothing. So kind of. So if you don't have enough data, for sure you have noise. So that's available easily. So you start with saying, well, I have noise, and you're going to introduce a generator, and you're going to generate fake data. At the beginning, the data that you're generating is going to look like noise. It's not going to look really nice. And what you want is to generate images, no, from a set of images that you have them very limited. So your real data is looking like that. So what we do next with this type of deep networks is to add a discriminator that is going to compare this fake data that is being generated and the real data, the very few examples that you have. And it's going to decide which ones are real, which ones are fake. You're going to introduce an error, and you're going to use that error to update the generator. And that same error is going to update the discriminator. So what you end up at the end of this process is with something like this. What you're looking at there are images from people that do not exist. A GAN created them. So, and that just kind of very important. No? So what we decided is like, okay, so I'm working in this agricultural area. We don't have enough images. So let's generate our own images with a GAN. And that's what we decided to do. So in our case, and this is the project that I was mentioning, we're working lately, is to classify dates. And into hard, soft, and semi-hard with a very limited set. As you can see there, we only have 1,800. So we definitely, if we're going to use a deep network, we needed more than 1,800. So usually what we do is, like I told you before, is there some pre-processing that you can do to help you? So we decided that if we added color to the original images, very simple step, we noticed that we, at the very least, the training aspect of it was getting benefits. No, we were being able to train a presently shallow neural network, deep network, and it was training faster. So this idea of introducing color was helping. So we started with those 1,800 images. We knew that we needed to separate them into testing set and training set. Our training set was very limited, and that's when we decided, let's bring in the GAN to create more examples for the training. And that's what we did at that step. So we call that step data augmentation. We're using GANs, and then we ended up creating images like this one, no? So those dates do not exist. We created them, so we increased our training set from few hundreds to thousands, no? And that's what we did. We train a 3-class classifier with a deep network. Now that we have more images to train, we used a ResNet, and these are the type of results that we have. As you can see there, not very good results. The soft cases in this corner here, if I can highlight it there, seems to be doing reasonably okay, but definitely failing on the hard and the semi-hard. No, and then we figure, okay, if we had only hard and soft, just extremes, maybe we're gonna do a better job. So we train another ResNet, but just for the 2 classes, soft and hard. And these are the results. And as expected, or we were intuitively saying, yeah, you know, you're reaching good results, but that's not our problem. Our problem also had those semi-hard cases. So the idea next, having trained those 2 classifiers, is how to combine the results. No, so we trained them and said, okay, they're going to make a classification. Some of them will be errors, but there will be a probability associated with how likely that classification was correct. So we call that, and of course, you're going to do that with the testing images. No, you're going to generate some scoring in form of probabilities from 0 to 100. And we decided to use those scores from the 2 networks and combine them. No? So for example, if you only work with the hard images and feed them into those 2 classifiers, of course, the red one is the 2 class. It's just going to have those 2 options, hard or soft. And that's what you're looking at, how those scorings. If we use the 3-class classifier, that now you're going to start classifying as semi-hard, which is the E that you see there, and making mistakes. We already know that that 3-class classifier wasn't very good. And if you introduce the soft images and feed them into those 2, once again, the 2-class doing a very good job for the soft cases, and the other guy making your life a little bit more difficult, no, the 3-class classifier. Then if you want to see the cases for the semi, of course, the 2-class classifier is not classifying any semi, we didn't feed that. And here is the 3-class classifier classifying like that. Then we realized that there are certain levels that let me show you there, that actually if you are above certain level, you should trust the 2-class classifier. And if you're below that level, you should really trust the other classifier. And that's when we came up with the idea, let's combine all these scorings into a final classification. So we decided to use an expert system for that. That is a very last step to make the very final classification. And that's the expert system that we use. And the type of results that we obtain are highlighted there. So notice how the classification went up for the soft and the hard, still having a little bit of a hard time with the semi cases. No, so we further inquired what the minimum expert was doing, and we noticed that at this step, it was just making classifications in very few images. So it was only choosing 18 images for final classification at that step. And not only was using very few or selecting very few, it was doing a very bad job. So we said, well, what if out of those 300 testing images, we decide that those 18 will be classified by an expert, by a human expert. And of course, we assume the human expert will do it always right. So if you make that modification to this algorithm, you go from this type of accuracy and introduce the manual expert for few cases to this, no? Where you are going to achieve 100% of hard cases, 100% accuracy on the soft, and the semi is still giving you a hard time. No? So that's what we have done lately, like very recently. We're about to publish this, like I said, together with the University of Barcelona. And I'm gonna stop here. I know it's a short talk. So I would like to once again thank you very much for inviting me. And that last image that I added is with a purpose. We know that technology has had a great impact on agriculture, and that image is me telling you it has had a great impact on humanity. So anyways, that's my talk.
Great, thank you so much. Yes, I think the last image speaks well to the past and also where we're going with technology and agriculture as well. So if you have questions, please feel free to add them in the chat, and then we will discuss them after our second speaker, and we'll address all of them. So our second speaker is Dr. William Aderholdt, who's located in Fargo, North Dakota, and is the director of the Program Management Office at Grand Farm Research and Education Initiative. In this role, William oversees the technology and projects at Grand Farm, bringing together organizations from around the world to demonstrate, research, and develop innovations in agriculture technology. Each week, he meets with startups to better understand their technology and how it fits into the future of agriculture. While completing his PhD, he worked to learn software development and data science, which allows him to connect deeper to modern technology innovations. So I will hand it over to you, William. Thank you.
Yeah, thank you. I am going to present my screen here in a second, but I did want to mention a little bit different than Gabriel or Dr. Thomas. My background is actually in sociology. And so for me, the conversation around ethics in agriculture comes back to the society, cultural, and traditions that get impacted by technology most often than not, and how can things like political decision-making impact our ability to create new technologies. And I think that all comes together. I think Dr. Thomas is right on the right page in terms of some of the stuff he was talking about. My screen's showing, I got a presentation up. Okay, so like was mentioned, I'm part of Grand Farm. Grand Farm's a 2-year-old project out of Fargo, North Dakota. I would say we work worldwide at understanding agriculture and agriculture technology, mostly in broad acreage agriculture applications. We have recently gotten more into indoor agriculture applications and things like space agriculture applications. But really what we're doing is we're facilitating an environment that organizations can work together, collaborate, and innovate. So to start, really, where did Grand Farm come from? So you can understand kind of where this all fits into the theme here. But there was a discussion by the person up on stage here at this TEDx conference. His name is Barry Batchelor. He put the first computer chip in the Steiger tractor. And when you think about automation and some of the pieces regarding software, that's kind of where it starts, is once you start to be able to do those things. There is things you can do with mechanization that can create some automation, but for the most part, it comes with the computer systems allowing us to amplify that. But he asked this question at our conference. Every great community that wants to make a worldwide impact has a major. What's ours? And before that, I don't know if Fargo had really thought about that. And coming together, building a relationship with the community, and building a roadmap, we came to this idea that ag tech was that centerpiece. And we realized that while ag tech's that centerpiece, we need to understand the challenges of ag tech before we can move forward with the project. So we looked at the challenges. I think this is a very common one that's discussed in agriculture. We're looking to feed 10 billion people by 2050. The estimate I just saw on a recent article was that means 70% more food is going to need to be produced than today. Although it's a 30% increase in population, 70% more food will need to be produced. That's a pretty big challenge to overcome. Another big one is lack of venture capital. So if we're looking at people like startups to get involved and build things like AI applications, they need to have the funding to back them so that they can move forward. One of the things we found was in the upper Midwest, organized venture capital was extremely lacking. And one of the things that hit home was when you looked at North Dakota, we actually had a not applicable when we looked at the top venture capital companies that were investing in our companies. So that was unfortunate. We recognized kind of what was mentioned was there's a skill gap in the workforce. And this one is specifically looking at if we brought in ag tech startups, they would need technologists. And Microsoft released a report March 2020 at the beginning of COVID that they were anticipating that there'd be 250 million unfilled jobs throughout the world in software engineering. That just, there was no people to fill them. And unless there was a change in workforce development, we weren't going to be able to fill the jobs in technology and keep up the pace with the innovations that were occurring. And so the big piece here is really how can you create technologists and upskill the environment. One of the ones Dr. Thomas hit on that I really hits home is the reduction in, or the reduction in farm labor. That's not just the farmers, which on here, 73% reduction in family farms in the last 50 years. 67% of the population is on 3% of the land in the United States, 52% reduction in farm workers over the last, I think it's 50 years. But, if you look at harvest season right now, everyone is hiring and no one can fill it. Every single radio commercial, every single TV commercial, people hiring, how many bonuses were going out and things like that. I know the next challenge that really hits home is not on this slide deck, but I'll just say it anyways. It is safety. It's safety in agriculture. I think anybody who's working in agriculture knows someone who's been dramatically injured or killed while doing their job. It's a very dangerous job. It's one of the top 5 most dangerous jobs in the United States. In many countries, it is the most dangerous job present. I know in our community just 3 weeks ago, we had a sugar beet truck roll over and kill the driver. I mean, that's the sort of thing that hits home when your industry is agriculture, and these are the people that you live next door to. So based on those problems, we went out to set out a strategy. The first was we knew we wanted to build a worldwide, world-class ecosystem in agriculture technology. To start with that, we looked at everything from startups, corporations, higher education, governments, and growers to come together and build an ecosystem that could really be mobilized into what we're calling our innovation platform. And so that's where we can take the work that innovators are doing and begin to add wheels to it, begin to connect them to growers so they can provide real-time feedback into technologies and understand what's going on, to take corporations who have financial capital or have existing platforms that those startups can build on and bring them together into a shared space that's neutral, where they don't have to worry about as much IP, but more so focus on collaboration and moving forward the needle. Our Grand Farm test site, our innovation site, is really this environment we have, a physical environment where those sorts of relationships can come together. We did start a software development school, and we are going to be looking at developing a data science curriculum as a second phase here shortly, called Emerging Digital Academy. And that is focused on the coding and robotics skills that are necessary for ag tech jobs. And then policy. So looking at all the policy barriers that currently exist, precedent that's been set through legislation, things like that, and understanding how innovators can begin to inform policy by connecting closer with the decision makers ahead of time and say, hey, here are the barriers we're running into. Is there anything we could do about that? And that happens almost, you'd be surprised, it happens almost all the time. If you're looking at an autonomous truck, there is likely barriers, depending on what state you're in terms of the laws and everything, to move forward. I'm not going to really get into our roadmap. There it is. That's what we've done over the last 3 years. Some of the cool things we'll be doing is actually building our facility next year. I think that's the coolest one. So we did start to plan out and build a facility that should be breaking ground here next year. And that'll be on about 160 acres of land. But the test site, in terms of kind of getting into the conversations that occur, is where a lot of these topics come up. And I'm going to talk a little, I'm going to hit them broadly. I'm just going to like scratch the surface, and then I kind of want you all to dive into things you're interested in. But again, labor shortages. So when we're thinking about AI and creating more efficiency through automation, that's a piece that hits home to farmers where they're concerned about losing their farms. And so there's a lot of work that needs to be done in AI literacy as a piece to help people understand what's happening, understand that AI is a spectrum, that it's not just like flip a switch and your job's gone, but there is a spectrum to implementation. There are a lot of assumptions from the innovators about what can be done with autonomous equipment, AI decision-making. So an example of that is, just because a farm is private land doesn't mean you shouldn't put in all the safety measures necessary to protect that land and the people around it. And so I think I see a lot of innovations happening that happen very quickly because there is no regulation framework that's happening on private land. And so there still needs to be the conscious effort to identify the risks and the things that can happen on the farm. As Dr. Thomas mentioned, to train any of these models and to utilize them, you need a substantial amount of data. Data ownership is one of the biggest things I get talked to about from the farmer, from the innovators, from the government. There's a lot of questions about who owns the data. If the data comes off my farm and I am the owner of the land and I choose to let it go, is that my data still, or does it belong to X or Y company? If I lease the land to someone and they do something that collects data and sends it out, is that the leaser's land and the data they own? can they still utilize that? And if I buy a piece of machinery, should it opt directly to send my data to the manufacturer, or is that should that be an opt-in system? Those are all sorts of things that we talk about almost all the time related to data, since it's so necessary when we think about AI. And the other thing is data resolution needs. Those are another big things that happen on this test site that we talk about. So does it make, I can collect a ton of data if I have 20 sensors per acre, but that's going to cost a lot of money. Does it make sense to have that, or does it make sense to have one sensor every 100 acres? Those are questions that need to be looked into by researchers to understand what is the value proposition to growers as they try to build data resolution that allows you to gain probability in these decision-making models, because the probability increase in the efficacy of those models is what's going to lead to greater yields, right? But you don't want to do it at the expense that you're spending more than you would gain in the yields by putting on the technology onto your farm. So this year we had 320 projects on the Grand Farm with 53 different organizations. We had 53 events on the Grand Farm that facilitated these sorts of conversations, and we had 1,900 visitors that came to the farm, and we engaged over 60 countries in those conversations. And it was just a fantastic year, and you can see the previous year stats there. I don't really need to dive into Emerging Digital Academy here, but some of the cool things that I like to talk about is we had a 92% placement rate of now 39 graduates in just 1 year, and their salaries within the 20-week program are doubling. So I think it's 130% increase was my most recent number that I pulled. 130% increase from the time they started to the time they ended. In terms of technologies we utilize, I kind of look at data in two different ways. It's data up and down the value chain, like from the input, which you see on the left-hand side, to the end consumer, which you see on the right-hand side here. So you have the shopping cart, the person who buys the bread at the end of the day, and you have the seed that went in to develop the wheat, right? That is the traditional value chain. Now, what we also have is the data value chain. And that can exist in a lot of different ways, but I like to work in what are called digital adjacencies. So I always look for companies that are nearby each other that could form, real collaborations. There are 14 different technology verticals on the Grand Farm. Those are all represented below in terms of some of the technology I work with on a daily basis. So really cool stuff. And all of them use AI, all of them use web applications to portray that data. And then we're also talking about ways that those communicate to portray data between them, to get from raw to decision-making power through whatever methods used. So there's just like some partner stuff that we have. These are some of the groups that have been involved. It's not 100% accurate as of today. And then I would say if you want to get involved with the Grand Farm, we love to have people engaged in the conversation, come to events, talk, but grandfarm.com, I'll put it in chat, is the best way to contact us and get linked in.
Great, thank you both so much. I think what's really interesting from both of your perspectives is really this idea, and I think Dr. Aderholdt, you said it first, but this like designed around challenges, right? Like I feel that Dr. Thomas is addressing this through challenges, right? Like not enough data to create enough efficacy in results. But I did see a question in the chat here before I get into my questions. Pull it up here. Yes, and if you do have questions, please add them into the chat and we'll read through them. So one question is, every domain where AI is used has its own ethics issues. Healthcare, facial recognition, and education are some examples. What are the ethics issues when AI is applied to agriculture? So maybe Dr. Thomas, or either if you have something that comes to mind, you can both go ahead. And so the question was, what are the ethics issues when AI is applied to agriculture?
I can see the controversies in other areas clearly, but I was discussing this with you the other day, and I'm gonna look very biased, but in terms of agriculture, I'm open to the discussion. To me, it's a win-win situation. So for the topics that have been discussed, the shortage, the chemicals, like I said, like the danger aspects, that's all I can say, but knowing that I might be extremely biased and somebody else may have a different opinion, but that's my opinion.
I mean, there's precedent set to me. There's been precedent set in agriculture and how it's been run as a business and an industry for so long that I don't think is ready for digitization. It's not ready for data engineering as a field to come into fruition. I think data engineering is going to be way more impactful than most people are predicting in agriculture. And if you don't have a background in data engineering, basically it's to, an idea could be creating a simulated environment. Like on the Grand Farm, we're working with Microsoft to develop out a digital twin through their air sim platform. And that would create almost like a data layer, a twin environment of the Grand Farm, 1-to-1 scale, high resolution, same physics and everything that you could test out and do things. Now you can imagine how training right now, based on the seeds or developing seed technology could take years. Data engineering can make that days. And so there's everything from chemical technology, seed technology, crops, different vehicles. There's a lot of IP laws in agriculture that might need to be looked at. I'm not saying they need to be looked at, but in general, if I develop out a seed variety right now, I own that seed variety. And so there is a potential of developing out ideas of one. You can see this in AI and developing of like music rhythms and saying, hey, I want to own all the rhythms my AI say is going to be really profitable in the future. I want to own that IP. Does that create a competitive space that people can't participate in? Does that negatively impact the farmer? Because then people can hike up the rates because they can specifically say, for your farm, I know exactly the seed type. I can develop that seed type using things like CRISPR to really, set in the best yields. And so there's a lot of things I think that are going to be discussed here in the future as we dive into some of these technologies. And like I said, there's things like I can create an autonomous robot right now, even as a hobbyist, and have it go on the Grand Farm and run around. Does that mean it's safe? Does that mean, there is no regulations about that currently on my farm environment? But, is there a responsibility to protect the user? Is there a responsibility to protect the land? And I think those are things that are going to need to delve into a little bit as we look at ethics in AI in agriculture.
Yeah, I think you bring up the good point of where is the responsibility in a lot of these things. And I think that just comes with pretty much how AI has affected every industry. It kind of disrupts and has us re-question, where is responsibility lie here? Who is responsible in this scenario? And I think it, like you said, it will take time for us to kind of address some of those questions and on a broader scale, which brings up one of the questions here. They say, I can see the benefits of AI for large-scale agriculture, but how do you foresee automation affecting the future of small-scale agriculture? And I know that small scale might be a little broad, but maybe not the the conglomerate farms per se.
I can hit on that. I read an article this weekend that there's an indoor agriculture operation that just fired up. It's not small scale, it's the largest one that's been developed. But often indoor agriculture is looked at as small. It can produce 30 times more food than traditional agriculture approaches with 90% less water. I don't think that there's an ethical thing there, but there is definitely AI in that facility, right? So even if you were to look at like something the size of the room I'm in, which is a guest bedroom that was converted to an office at the beginning of COVID, if I were to develop out a indoor agriculture operation in here to develop strawberries, which are not really huge in North Dakota in terms of growing, I could do that really well if I have robots assisting me at every single point and sensors taking all the measurements at every single point that have been trained to know what to do in different environments. So in terms of like, if the moisture level drops, add a little bit of water. Now, if I were to do it on my own, that would look a lot different. I'm awful at indoor houseplants. I kill them all. But so there's a whole, I think it's completely different. And the same thing in terms of specialty crops that are in outdoor environments, right? Like you're going to be looking at things like controlled environment agriculture. You're going to be looking at irrigation, drainage. You're going to be looking at those things that all are utilizing AI now to develop out decision making about when do you do these things that create a competitive advantage if you're using them versus not.
Dr. Thomas, anything? No. I would add on to that too. I think, the definition of small scale has changed over time in agriculture itself. But I mean, even just on a personal level, like you can have an app on your phone that you can identify various leaves. If you're looking at a weed and you're like, I don't really know what that weed is, you can just, get your smartphone and have an app, and it tells you exactly if that is a weed or a beneficial plant or whatnot. So I think, depending on the scale, I think in those little ways, it has positive effects in that way. Yeah. Oh, sorry.
No, what I was going to mention is scale. Here in Manitoba, I remember talking to farmers, and they said that because the sheer amount of hectares covered by a single farm, they usually own their harvester. So it wouldn't be uncommon for a big farm to own a harvester. Now, coming from my background in Mexico, like you don't dream of having a harvester. No, you're very, you don't have the resource. So it will be the harvester going into towns, and you will rent their services. So it's a totally different scenario, not only in a scale, but you're talking about a developed country and an underdeveloped one. So I can only hope that that technology will allow those poor countries that not only scale in size, more access to that. I don't know the way, but maybe if the harvester, because of all the technology, maybe even at the government level, they're the only ones who can provide that. It will be more efficient than maybe it can reach, because this idea that you have to rent a harvester is not just the expense that you have, although the other one has to sustain it. It's also that if it's raining, you have to take a turn, and then you're just very worried because you're waiting for the harvester to come, and of course it's busy in another place. So any sort that I see, once again, I'm biased, that you can increase the usage of that harvester. Maybe you can operate it at night now because of automatization. Now you don't have to be that worried about, it rained, I cannot use it right now, no, and I have to wait because my neighbor is using it, is renting it, and so on. No?
Yeah.
So another question here. Why don't small scale, oh, sorry, I skipped one. Towards the IP discussion, given that big tech has optimized for harvesting and monetizing human generated data, why would we not expect big ag to do the same?
Sorry, what was the question?
Towards the intellectual property discussion that we were having, given that big tech has been optimized for harvesting and monetizing human generated data, why would we not expect big agriculture to do the same?
That's a can of worms. Somebody's opening.
That's that is a can of worms. I'll hit on it because we've been involved in some data conversations to date. But like I mentioned, I believe because there isn't a regulatory environment, I'm not saying there needs to be created one. Most software applications that have to do with farm data you have an option to turn on or off data sharing, but it's often defaulted to be on. And so even big companies, even startups are, looking at that piece, and the data is extremely valuable, both for production in-house in terms of innovations you're developing, but also to sell to develop out these data-driven models. We have begun to see relationships develop between farmers and large organizations that could, you could sell the data. We've seen companies, one of them, for instance, I've seen is Bushel, looking at helping farmers monetize data at the end of a growing season as a part of selling their crop. To me, those are, starting to work with the farmer. A farmer is a business owner. They have a business to run too. And so finding ways to be collaborative in that environment, where I think everyone wants that data, everyone wants to make money off it, but finding ways that it respects the right of the farmers in that discussion is where I think it'll end up going.
Dr. Thomas, anything? You don't want to get into the can of worms.
I can say something, but I don't know if I want to be controversial. All I can say, let's say that there's an hypothetical country that says that they're going to be the Saudi Arabia of artificial intelligence because they can have access of data without asking you if you want to. And they have a point. If we don't have to deal with those issues, especially, for example, in medical imaging, we have a huge database in Manitoba for accessing that. Well, there is the database, but access to it is extremely difficult. And I understand that, no, for the ethics behind that. But I just want to mention of a certain country that claims that they're going to be the Saudi Arabia of artificial intelligence because how easy they can access data. And I'm just throwing it there. I think they have a point. And I'm not claiming that data should be more available, that we should be, the regulation is important. I'm claiming that, but in terms of competitiveness and things like that, maybe countries like the US, Canada, we would like to think a little bit more about, okay, so we understand the privacy of the data, but we also have to start thinking about these things. No, let me just put it out.
Yeah. So let's see here. Are either of you familiar with Tree Farm America?
I am not.
No, okay, then we will skip that one for now. Food forests. Have either of you looked into food forests? Not Dr. Thomas Aderholdt?
I have not. No.
Okay. So let's go to Elizabeth's question here. Would big tech increase negative implications on the environment? How could these be minimized? So taking the implications of AI-enabled agriculture machinery on the environment, is there anything that you've seen that could be minimized in these ways?
I would say, I just want to build on what Dr. Thomas was saying to kind of understand, because I'm a sociologist. Like I said, I think things should respect cultural, sociological, traditional ways of being as it relates to these technologies. But if you put a business out there and the customers don't care or it's not regulated, they're going to do what's best for their business. Unless there is some discussion about the consumer caring where they got their information, at least there's, that's where we're starting to see carbon become a bigger and bigger topic in agriculture right now, is people care about ESG. People care about where their food's coming from. And so it's driving decision-making in bigger companies to do certain things differently. I think it's going to be the same thing in agriculture. Is people are going to do what's going to be best for them to be able to be competitive as a company. And if they see their competitors doing it, they're not just going to say, hey, I'm going to let them do that. They're making a ton of money off it, but I'm going to be off to the side. That doesn't really make business sense. And so what it comes down to is really this subjective environment. I think a lot of this, the ethics side, which is why it's so interesting, is it really comes down to what is right and what is wrong. And it's so subjective. It makes pretty clear sense depending on what society you're in, but for some societies it doesn't. And that's looking at a global economy, those are things that need to be discussed. Those conversations are happening. I think that ESG is a great example of how this environment has begun to shift. I think that also, like I said, AI literacy has been huge for agriculture. I don't think farmers are stupid by any means. They're starting to think about what data means and AI means and all this stuff means. And they're starting to put themselves in the middle of the conversation, which is changing things, because the end consumer of like a tractor is the farmer. They're the one who are going to go and buy it. And so they're going to care what's going to happen to their data. It's going to change their decision-making if they don't think they're going to own their data or they're not going to have their privacy. And so it all comes down to education, society, what people want to see, what the end consumers want to see, and things like that.
One way that I can see it being impacting directly, I do think about the waste that we use in restaurants and we as consumers, especially if you're a man like me, you don't find things on the refrigerator and they spoil. And I think the amount of food that we waste is a lot. So if we can introduce technology for that, like for example, you go buy groceries and they're scanning the products. They can send you the information and expiration date. So by the time you make a decision of what you're gonna cook, you're gonna go for the produce that it's about to expire. And I think indirectly you're affecting the environment because you don't have to produce as much. So if you, by any chance, there is some hazard on the environment because you're producing a lot. So if you reduce that amount of waste, indirectly you are benefiting the environment. And I think that would be one approach, no? That if you can also introduce this idea, not only are we not gonna waste it, but we don't have to produce as much and don't affect the environment in that way.
Yeah, I would add on to, and so going back to the Tree Farm America, and I think you had mentioned it a little bit, apparently Tree Farm America, they can now sell carbon credits even on tiny tracts. So perhaps it does play into that idea of tracing, right? Data tracing. I was going to mention, and it's kind of slipped my mind here a little bit, but essentially I like this idea of for me, when I look at AI ethics, I'm really, well, in agriculture specifically, I'm really more worried about having the farmer involved in the process. And I think that to me is what makes AI in agriculture ethical, is having the actual farmer involved. And I think that when we're looking at other industries, that's not always been the case. We've had other industries where there are developers that develop the AI, it's deployed, and that's the end of the discussion. Then there's ramifications that kind of trickle down. And I do like this. I think we've seen it historically, and you know, coming from that social science perspective, Dr. Aderholdt, like farmers have always been involved in policy and been involved in government and been involved in these conversations. And I think that often gets really overlooked, is that farmers kind of are seen as just like these passive people that just take their machinery and go out in the fields and then give us everything we need. And I think that's really, that narrative here has a chance to change, because through innovations like, you know, Grand Farm, seeing how farmers can actually be involved in the process, which I think is really important. And then we have an alumni from Illinois Tech, Craig Roop, who has developed Sabanto, and he has been really revolutionary, I think, in having farmers involved in the fields, right? Like, we're not doing this in this metropolitan area. You'll see him in the field with farmers developing the new technology and learning from them, not only the business needs, but like the social needs, right? Like, and I think that will be where AI ethics can really take a part in agriculture, is, you know, finding the balance of how much human we want in the process yet, because like going back to the first thing that Dr. Thomas said, nobody wants to be getting blisters and breaking their back or injuries like Aderholdt was saying. So I think, yeah, we're just at the beginning of this discussion, and I think we have a long way to go, but I really appreciate everyone for joining us. If there's any final questions, we can add them in the chat here. You can check out Grand Farm there from Dr. Aderholdt. And yes, I'll give it a couple minutes if you can think of any questions that you have on your mind. If not, then
I did want to mention something about Craig and other entrepreneurs.
Yeah,
So we work with Craig. He actually loaned us one of his Sabanto ag tractors for 2 years.
Oh, wow.
So an autonomous tractor, you know, really cool environment to work in. We've also got Soil Tech Wireless, which is a cool sensor. Now, and that's from this founder called Hassan. Now, what kind of sets them apart, and what I wish we would see entrepreneurs do more as they're starting up their businesses, is exactly what you described. You should start with the grower. I can tell a complete difference when I'm on a call with someone if they've been working with growers for years on their innovations, or if they're a company, and there's many that I've met with that have never talked to a grower about their technology. They're just producing it in a vacuum, thinking that it will apply to agriculture. If you start with the grower and you talk to them, you get their buy-in, and you hear about the problems they want to solve, you're gonna come out probably with a really good product. Everyone that I've met with, that the first thing they did was talk to a grower, They're the ones the VCs are looking at. They're the ones that people want to invest in, and they're the ones that are doing really good in terms of uptake. And so, by understanding what the challenges grower associations, councils, growers, elevators are facing at the core, like the boots on the ground level, I think that's where we can start. And I don't know if you're going to run into a lot of ethical issues if you're doing it that way. I think it's a lot of times where people just go out and do things thinking it's going to be great, and they're not taking into consideration that these are people's lives, businesses, communities that they're disrupting. That's where you start to run into a gray area or a zone that you wouldn't want to be in.
Yeah, 100%. All right. Any final thoughts, Dr. Thomas, Dr. Aderholdt?
Just to add on that, that's very important, the topic that you touch. Sometimes in technology, especially the person in my side, we are so focused on solving the technical aspect, and we kind of like don't think a lot about the implications, the social implications, or talking to a farmer. And some of us, we're very well known at that. No, we're so excited about solving this specific solution with this level of accuracy, and all we carry is numbers. And definitely the involvement of these people is very important. No? They're the ones who can guide you into a product that not only going to achieve this accuracy, but is actually meaningful positively in the lives of people. That I totally agree. And we tend to go into the numbers and more technical aspects.
Yeah. All right. Well, I will thank you both again so much for joining us today. I really appreciate your time and perspective and expertise. And let's see. Being perennials, because in the soil okay, I'm not sure where that one's going there. But all right. Thank you, everyone. Have a great day. And I look forward to connecting with you all. Please find me on LinkedIn if you have any further AI and agriculture questions, concerns, comments, and we will keep the discussion going. Thank you.